Hello, and how are you? My name is James, a teacher of mathematics in secondary school, and I want to tell my students who are watching me from home that this is an important lesson. We are going to look at indices and logarithms as covered in Form 2 syllabus. So for our Form 3 and Form 4 students, lesson is equally important to you, especially for our candidates who are preparing for their Kenya Certificate of Secondary Education. For you to benefit maximally, please get yourself some reading materials, get yourself all the tools that you need so that you can be able to move together in this lesson. We are going to look at indices and logarithms, and for this lesson we are going to look at indices. Indices and logarithms. We shall look at indices. In this case, we are going to look at what indices are and also look at the laws of indices in this lesson. The first thing for us to understand what indices are, consider if you're given a number such as 2 to power 3. This means 2 times 2 times 2, and 2 times 2 times 2 is 8. So 2 raised to 3 is 8. This means that the number 3 is referred to as the power or the index, and the number 2 is referred to as the base. Therefore, the short form of writing 2 times 2 times 2 is 2 to power 3, and 3 is referred to as the index. Of course, index is in singular, and when we talk about in plural, we are talking about indices. We can have another example. Let's call that one example A, and we also have example B, where you have 3 raised to 4. This will mean 3 times 3 times 3 times 3, and 3 times 3 times 3 times 3, that will give us 81. So together we are going to say 4 is the power or the index, and 3 is the base. So class, I do hope now, if you are asked to explain what indices are, you are in a position to do so. The next thing you're going to look at is the laws of indices. The laws of indices are basically, consider if you are given a number a to power 3, you multiply that to a to power 2. So this will mean a to power 3 is the same as a times a times a times a squared, which is a times a. Opening the brackets, you're going to have a times a times a times a times a, which will give us a to power 5. So meaning a to power 3 times a to power 2 is a to power 5. Alternatively, you can take a to power 3 times a to power 2, and instead of doing all that, we add the powers so that we have a 3 plus 2. And you realize that our answer becomes a to the power 5, the same as that. Therefore, we conclude and say, if you are given a raised to m times a raised to n, then add the powers and you shall have a m plus n. This one, we refer to it as our first law of indices. And later on, we're going to see how that one will help us solving certain problems. Class, we are now going to look at the second law of indices. The second law of indices. Now, consider you're given a raised to power 5 divided by a raised to power 2. This is the same as saying a to power 5 divided by a to power 2. And a to power 5 is the same as a times a times a times a times a, 5 of them, divided by a squared, which is a times a. And then you cancel out the a's, and then you shall be left with only 3 of them, and that is a to power 3. Alternatively, you can say a to power 5 divided by a to power 2, we subtract the powers, a 5 minus 2. That will give us a to power 3. You realize that that answer and this one are the same. Therefore, we conclude if you have a raised to m divided by a raised to n, then this one is a m minus n, as you have seen this one. And this one is called the second law of indices. Second law of indices. Now we are going to look at our third law. Consider you're given a to power 3 and that is squared. This means a to power 3 squared is a to power 3 times a to power 3. Using our laws of indices, we are going to add the powers, and this will give us a 3 plus 3, which gives us a to power 6. Alternatively, we can say a to power 3 squared, we just multiply the powers to give us a 3 times 2, and that will give us a to power 6. This answer and this one are the same. Therefore, we conclude that if you have a raised to m, all that to n, then that would be a mn. You multiply the powers, and that gives us the third law of indices. There's something I would want you to note in this case, that all the time, for these laws to apply, the basis must be the same. The basis must be the same. For these laws to apply, it's an important point that we need to take note of. That note for